how to make sense of the wild and crazy Protist Supergroup.
Do you know what a protist is? Most people don't. Most people, though, don't know that protists are wild and crazy. In other words, another way to look at wild and crazy is that there is a wild and crazy amount of biodiversity in this group. There are people that even blog about protists. If you check out our friend Beatrice the biologist, she asked the question, can you see how all these protists are related? Her cartoon answer is, no, me neither. I wanted to show you that you can think about how protists are related if you just break them down into a few simple questions. Your first question is to think about what is a protist, and to understand that protists really are everything that is not. Everything that's not a bacteria, not a fungus, not a plant, not an animal. Beatrice the biologist describes this as the junk drawer of biodiversity. Everything that you can't describe as something else is a protist. So I want you to be able to make sense of protists. Remember, protists are a big group. Again, everything that is not a fungus, plant, or animal, and most of them are unicellular. From the chapter that you read, think about how you would answer this question. What's your favorite protist? In terms of evolutionary relationships, at one time, protists were in a single group. However, protists is not a monophyletic group. Instead, the evolutionary understanding is in flux. Some relationships are uncertain, and new protists are still being discovered. Together, we classify those into supergroups. Within each supergroup, we talk about the ecological role. There are ones that are plant-like. Those are the algae. They tend to be photosynthetic. The second group are animal-like. We call those protozoa. They are heterotrophic, meaning they get their energy from somewhere else. And the last group is fungal-like, and these resemble fungi in body form, and they also use absorption as their form of nutrition. But overall, these terms, animal-like, plant-like, and fungal-like, lack some taxonomic or evolutionary meaning, and taxonomically, we group them into supergroups. The next series of slides that you will see will be an example of one supergroup and how to go through with a list of questions. There are 7 protist supergroups which you will want to learn and appreciate. Remember, these all fall in the new domain, and they're all eukaryotic. You may ask, how in the world do I figure out these protists? Let me give you steps to think about. Number 1, ask yourself, how is it classified? What is the name of the supergroup? Number 2, what is its distinguishing feature? Usually these are morphological. Number 3, what type of protist is it? Go back to the ecological role. Is it animal-like, fungal-like, or plant-like? Number 4, how does it get its energy? Does it do phagocytosis? Is it photosynthetic? Does it absorb nutrients, or some combination? What is its function? Decomposition, diversity, it may cause disease, it may produce oxygen. Think about how it functions in the environment. And lastly, think about an example. I also encourage you to add a Bioboost. A Bioboost is going out and looking on the internet or in sources to find something relevant and updated about that particular supergroup. One other thing that I find that makes protists easy to remember is if you come up with a catchy little phrase. And so, let's do it for the first group. It's easy to dig the early protists because their names are excavata. Get it? Excavate, a site is to dig, so it's easy to dig the early groups, excavata. So if you come up with some sort of mnemonic or catchy little phrase, it's much easier to remember the supergroups. In the next set of slides, I'm going to go through the first group of excavata, or the flagellated protozoans, to give you an idea of how to break down this group, as we will do with all the supergroups in class. So these are the flagellated protozoans. They live in anaerobic environments. They don't have specialized organelles, but they have very early mitochondria, and they generally cause disease. So the question is, what ties these flagellated protozoans together with other excavates? And the answer is a characteristic deep feeding groove. So either at the supergroup or the smaller level, you always want to ask yourself to connect between the groups. Now, I've provided this table for you to look at excavata. So remember the questions. Number 1 is, what is it called? What is the name of the supergroup? Well, flagellated protozoans are excavata. What is their distinguishing feature? They have two, really, the lack of plastids as well as the early mitochondria. What kind of protist are they? They're animal-like. How do they get their energy? Through phagocytosis. What is their function? They cause disease. And what is an example? Something like Giardia, or Montezuma's revenge. So after you go through the table for each of those questions in each of the supergroups, I encourage you to use the internet and other resources to find a Bioboost. And so I searched new research on flagellated protozoans, and this is what I found. I found this article in the Proceedings of the National Academy of Science where they looked at the imaging of flagella in these flagellated protozoans. And so the pathogen research actually inspires robotic designs for the medicine and the military. Who knew the Department of Defense was interested in the same parasite that causes Montezuma's revenge? That's an example of a Bioboost. Now that you know how to understand a supergroup, you need to go back through your textbook and outline each of the supergroups using the questions that I gave you. We'll compile these in class.